All right, question number 8 says the most famous geyser in the world, Old Faithful in Yellowstone National Park, has a mean time between eruptions of 85 minutes. If the interval of time between eruptions is normally distributed with a standard deviation of 21.25, complete parts A through F. So part A says, what is the probability that a randomly selected time interval between eruptions is longer than 95 minutes? Okay, so first, we were given that the mean was 85. The standard deviation was 21.25. And we're told that it's normally distributed, so we know we can use the Z formula. Z equals X minus mean over sigma. So part A, we are looking for the probability that any eruption is going to be greater than 95 minutes. Okay, so if we apply the Z formula, this is probability, and then Z is greater than, and we'll figure out the 85 minus 95 X value minus the mean, which is 85, over the standard deviation, which is 21.25. Okay, so we would apply this, get a Z-score, and then we would find whatever that value is on the table. So when we do standard normal, mean will be in the middle, 0. Since the 95 is greater than 85, this will be some number on the right side, and we will be looking for the area to the right. So just based on that, I can tell it's going to be less than 50%. But at this point, we've learned how to do it with StatCrunch, so we're going to use that and let it apply the solving process to the rest. So we're going to go to Stat, Calculators, and we're going to go to Normal. We're going to flip this to be greater than, because we want it greater than. The mean was 85. The standard deviation was 21.25. And we want to be greater than 95. That was our question, greater than 95. All right, so you can kind of see similar picture. Probability is 0.3189. The 6 will round that 9 up because we're going to go to 4 decimal places, so the 9 is going to go to 10 and carry over. So we're looking at 3190. 3190. And it should be pretty close when you use the Z formula. So 0.3190. All right, part B, what's the probability that a random sample of 7 time intervals between eruptions has a mean longer than 95? Okay, so part B, we're now applying the sampling mean distribution. So the difference here, standard deviation changes to sigma divided by the square root of n. All right, so we're still doing greater than 95. I would just do this same calculation, except the 21 will be divided by the square root of 7 in this case. But again, I'm going to use StatCrunch. I'm going to allow it to just speed up this process for us. So right here where it says standard deviation, I'm going to change this to divided by, and then SQRT is the abbreviation for square root, and then put 7 in there. So I'm going to put in parentheses SQRT 7. So everything else is the same. The mean is the same. Standard deviation is changed. We're still looking for greater than 95. This time the probability is 0.1065, and the 5th place is a 5, so it's going to round up to 1066. Part C, what's the probability a random sample of 29 time intervals has a mean longer than 95? So if we have our population changes, so we're looking at, this is greater than, still 95, just going to write this formula out. 21.25, and this time it's going to be divided by square root of 29. So this is what we would be applying and then finding the z-value. So again, StatCrunch, the thing we're going to change is our sample size. So over here where we have 7, we're going to change that to 29. Okay, so the probability that we do 29 is going to be greater than 95. It's going to be 0.0056, and that will not round up 0.0056. Okay, so what effect does increasing the sample size have on the probability? So as we can see, we started out with just a regular normal distribution. When we had a sample size of 7, we had about 10 or 11%, and then down here we have about 1%. So when the sample size got bigger, the probability of that happening went down. So if the sample size increases, the probability decreases because the variability in the sample mean decreases. What might we consider if a random sample of 29 time interval eruptions has a mean longer than 95? So if this was the case, which is very, very small chance, we got to look at these options and figure out which one is going to be the best response. And it says select all that apply, so there may be more than one. So the first one says the population mean must be more than 85 since the probability is so low. So must is a strong. I won't say must. It could be more, but we don't know. The population mean is probably less. Less would be the opposite. The population mean must be less than 85 since it's low. The population mean cannot be 85 since the probability is so low. The population mean is 85 minutes, and the example, this is an example of typical sampling result. The population mean is probably greater than 85. The population mean is 85, and this is just a rare sampling. So this one is the case. It could just be a rare sampling, and must be, I feel like there's another one that could fit too. Population mean is probably greater than 85 minutes. This one seems also possible. The population mean is probably greater. So if you did this and you came up with that result, it's possible. So this one just says it's possible that it's greater than 85, probably. Doesn't necessarily mean that it is. We don't know that for sure. And then the rest of them, I think, would not fit. Part F, which is the last one, says on a certain day, suppose there are 21 time intervals for Old Faithful. Treating these 21 eruptions as a random sample, there is a 20% likelihood that the mean length of time between eruptions will exceed what value? Okay, so here we are working backwards. Okay, so they're telling us the probability. So this is part F. So basically this is what they're giving us: probability, and they've already converted it to z, is greater than some number is going to come from here. So I don't know what that number is. That's what I'm looking for. Minus 85 divided by, this will be 21.25 over the square root of the sample, which was 21, and we are told that this is equal to 20% or 0.20. So we are going to use the standard normal. We're going to find the z-value that is associated with the area to the right being greater than that is 0.20. once I find Z, I'm going to work backwards, and I'm going to figure out what this sampling mean number is. So we're going to pull up the normal chart. That's the negative side. We want the positive side, which I could use the negative side. I can just find 20% and just flip the sign. So I'm looking for 0.20 on this row. Okay, so 20 happens between these two. This number is closer. It's 5 above. This one is about 23 points below. So this is negative 0.8. 1, 2, 3, 4, 5. So 0.85 is what we're looking at. So we have our Z value, Z, and we're only focused on this inside part. So Z is 0.85. And I'm just going to say, I'll leave it as greater than, that's my equal to part. X bar minus 85 over this square root part. So 21.25 over square root of 21. So we're going to multiply, and then we're going to add the 85. That's going to give us our X. So doing algebra and working backwards, we're doing 0.85 times the denominator, which is 21.25 over the square root of 21. And then we're going to have X bar minus 85. I'm going to add the 85. So this is plus the 85. And that's going to give us this X bar number that we're looking for. So we're going to let the calculator compute all of this, and then that'll give us our estimate. It says round to 1 decimal place as needed. Okay, so 0.85. We're going to do the 21.25 divided by the square root of 21. And then we're going to add 85. We get 88.9, so greater than 88.9. Now, if you want to test that, you could check it, pull up StatCrunch, go back to calculators, normal, put the mean of 85 in there. Should get pretty close to 20%. Standard deviation, 21.25 divided by, I'm going to do SQRT, and we had 21 for the sample size in this problem, and we wanted to check greater than, and the number that we came up with was 88.9, and let me confirm that, 88.9, and we should get close to 0.20 right here. Yeah, see 0.2001, which is a little bit rounded, so 88.9.